Hi, my name is Mladen Knežić and I'm from the Faculty of Electrical Engineering, University of Banja Luka. Today I'm going to present our work in progress paper entitled Implementation Aspects of Multi-Level Frame Preemption in TSN. Conventional frame preemption supports only single-level frame preemption. High priority frames, typically representing scheduled traffic, are handled by the EMAC or Express MAC. On the other hand, all other frames are treated equally and handled in FIFO manner so that low priority frames are effectively serialized. In this particular example, we have one high priority or EMAC frame and three low priority frames with different priorities, PMAC 1 to PMAC 3. PMAC 1 frame arrives first and is immediately transmitted. Next, high priority EMAC frame becomes ready for transmission so that PMAC 1 is interrupted. After EMAC frame is transmitted, PMAC 1 frame transmission continues, effectively blocking PMAC 2 and PMAC 3 frames, which leads to a missed deadline. Conversely, multi-level frame preemption concept allows for multiple PMAC units and PMAC frame preemption with respect of assigned priorities. In this case, PMAC 1 is first preempted by the PMAC 2. Afterwards, EMAC frame is scheduled as in the previous case. However, when transmission of EMAC frame is completed, PMAC 3 frame resumes, which becomes ready in the meantime, and it will be sent first so that the deadline is met in this case. This concept was first introduced by Mubarak Ojewali, Patrick Yomsi, and Jeffrey Nelson in their work in progress paper, and further analyzed in a feasibility study that was recently published. The original transmit and receive state machines, whose simplified structure is illustrated in the diagram, contains 15 and 70 states respectively. The authors in the previously mentioned study proposed a simple extension of the state machines by replicating the relevant branches. This leads to 8 additional states in transmit and 6 additional states in receive states machine per each preemption level. If we consider a realistic scenario with 7 priority levels, 8 VLAN priorities, of which one is assigned to EMAC traffic, we end up with 63 states in transmit and 53 states in receive state machine. In our approach, we introduce architectural modifications in order to address scalability issue of the state replication. More specifically, we add 2 multiplexers for selecting PMAC instances in transmit and receive paths. To manage priorities, we introduce a special logic block named arbiter. This block receives requests from PMAC instances and makes decisions based on assigned priorities. To support described architectural modifications, we had to slightly modify fragment structure by introducing additional field called MAC ID. This field is populated by arbiter in transmit path and recovered from the frame in receive path. It is used to identify the currently selected PMAC instance. Original transmit and receive state machines require minimal changes, only 2 additional states and modification of 1 state in each state machine. This means that transmit and receive state machines have 17 and 19 states respectively. More importantly, the state machines remain unchanged irrespective of the number of preemption levels. If you are interested in our work, please use the link shown at the bottom of this slide to access our repository and get recent updates about our progress. Thank you for watching this presentation.